Hello, madlang people, mabuhay! Good evening. Today, I am excited to delve into the fascinating field of environmental geography, where we introduce and orient you of the course. First, we are going to tackle the concept of the environment geography. Next, gross features of the Earth. Third, environment and the social sciences. Fourth, environmental problems. And lastly, objectives of the environmental geography. And now, let us move on to our first topic, the concept of the environment geography. On this slide, let's start with the basic. What is environmental geography? Environmental geography is a subfield of geography that focuses on understanding an intricate interaction between humans and nature in various spatial and temporal contexts. It delves into the spatial aspect of this interaction, requiring a comprehensive understanding of climatology, hydrology, biogeography, geology, geomorphology, and the diverse way in which human societies perceive and conceptualize their environment. This report aims to provide an overview of environmental geography, its core concept and principles, emphasizing its significance in addressing complex environmental challenges. To grasp the concept better, let's borrow the words of Susie Park, who defined the environment as the sum total of conditions that envelopes humanity as a specific point in space and time. In the next slide, environmental geography is closely related to environmental studies, an interdisciplinary academic field that seeks to systemically study human interactions with the environment. It encompasses both the natural and built environments and the complex relationship between them. And now, let's delve into the core principles that underpin environmental geography. First, we have the first principle, we have environmental system or ecosystems. The fundamental unit of the study environmental geography is the environmental system or ecosystem. These are complex networks of living organisms and their physical environment. Next, we have the principle 2, we have biospheric ecosystem processes. Ecosystems are not random. They are governed by discernible processes, including energy flow, nutrient cycling, and interaction among species. Next slide, we have principle 3, continuous creation and transformation of Earth's surface. Our planet surface is continuously shaped and reshaped. Erosion, sedimentation, and tectonic movements are some of the forces at play. 4. We have uniformitarianism in processes. Environmental geographers adhere to the principle of uniformitarianism. This means that the same physical and biological processes observed today have operated throughout Earth's history. Next slide, we have principle 5, homeostatic mechanisms. Natural environmental systems strive for balance through homeostatic mechanism. They work to maintain equilibrium in the face of disturbance. Next, we have principle 6, reciprocal relationship between abiotic and biotic components. Relationship between non-living and living components in ecosystem is reciprocal. Each influence the other. Lastly, we have the principle 7, energy flow and nutrient cycling. Energy flow and nutrient circulation are essential for sustaining life on Earth. This process underpins the web of life.
So, good evening everyone. Before we start, reporting my topic, let's have an overview about the Earth. So, Earth, or also known as the world, is the third planet from the Sun and the only object in the universe known to harbor life. So, the Earth is the densest and the largest among the terrestrial planets. So, Earth formed around 4.5 billion years ago. 29% of it is visible land and 71% of it is surface is covered in water. So, first is how did the Earth form? So, Earth formed when gravity pulled swirling gas and dust into become the third planet from the sun. And the second is what is the shape of the Earth? So the shape of the Earth is approximately oblate spheroidal, and Earth is 40,075 kilometers around, and its widest point, the equator. So the third one is the size and its distance. So with a radius of 6,371 kilometers, Earth is the biggest of the terrestrial planets and the fifth largest planet overall. From an average distance of 93 million miles or 150 million kilometers, Earth is exactly one astronomical unit away from the Sun. And fourth is orbit and rotation. As Earth orbits the Sun, it completes one rotation every 23.9 hours, and it takes 365.25 days to complete one trip around the Sun. And Earth's axis of rotation is tilted 23.4 degrees with respect to the planet of Earth's orbit around the Sun. So next is chemical composition. So Earth's mass is approximately 5 septillion and 976 billion kilograms, and it is composed mostly of the following. Iron is 32.1%, oxygen is 30.1%, silicon is 15.1%, magnesium 13.9%, sulfur is 2.9%, nickel is 1.8%, calcium is 1.5%, aluminum is 1.4%, and the remaining 1.2 consisting of the trace amounts of other elements. So now let's proceed in internal structure. So Earth is composed of four main layers, starting with an inner core at the planet's center, enveloped by the outer core, mantle, and crust. So first is the crust. It is very thin in comparison to the other three layers. So the crust is only 8 kilometers thick under the oceans or oceanic crust, and about 32 kilometers thick under the continents or the continental crust. So the temperatures of the crust vary from the air temperature on top to about 870 degrees Celsius in the deepest parts of the crust. And the crust of the Earth is broken into many pieces of plates, or what we call tectonic plates. Next is the mantle. So mantle is the largest layer of the Earth. It has 2,896 kilometers thick, and the temperature of the mantle varies from 871 degrees Celsius at the top to about 2,204 degrees Celsius near the bottom. So mantle is composed of very hot dense rock, and this layer of rock even flows like asphalt under a heavy weight. Because of this, the plates float on it like oil floats on water. And next is the outer core. So the core of the Earth is like a ball of very hot metals. The outer core is located about 2,896 kilometers beneath the crust and is about 2,253 kilometers thick. It is composed of the melted metals nickel and iron. Unlike the inner core, the outer core is not under enough pressure to condense it into solid metal. Instead, it remains in a liquid form surrounding the inner core. However, the liquid metal form of the outer core is also caused by its extremely hot temperature, which is about 4 times hotter than lava. The outer core was also measured to be about 50 times stronger than the Earth's magnetic field at the surface. And lastly is the inner core. So the inner core is solid in state. The inner core begins about 6,437 kilometers beneath the crust and is about 1,287 kilometers thick. And the metals are compressed tightly together and are forced to vibrate as solid. The tremendous pressure causes the inner core to form into a solid mass. Most of this layer comprises iron, but scientists theorize that it also contains other elements such as sulfur, potassium, and carbon. The temperatures may reach 4,982 degrees Celsius and the pressures are 45 million pounds per square inch. This is 3 million times the air pressure of New at sea level. The inner and outer cores create the Earth's magnetic field, and the Earth rotation causes the core to spin, which leads to creation of an effect that maintains the Earth magnetic field. And because we're done discussing about the gross features of the Earth, now let's proceed to the environmental and the social science. So, environmental social science provides knowledge and insights about the interplay between society and the environment. So, environmental social science is the application of social science, broadly the study of the relationship between individuals and their context within society, and its application to our understanding of environmental issues. So the present volume grew out of a realization of the part of American Psychological Association as well as the editors that psychology had a substantial contribution to make a better understanding of our present day environmental problems and to a more effective approach in dealing with them. So, environmental concerns affects a man-environment interactions. Environmental social science aims to better understand how the relationships between people, science, and nature affect the decision we make and the actions we take. It blends environmental science, social science, political ecology, science and technology studies, science policy, and science communication. Environmental social science explores everything from individual thoughts, perceptions, and behaviors to systems, thinking, and complexity of international governance and social change. Such an approach is crucial for navigating towards socially just and environmentally sustainable futures. It collaborates with experts in law, policy, geography, environmental science, design, engineering, mathematics, and statistics to generate creative solutions to ecosystem management issues such as bushfire, forest management, water resources, land management, biosecurity, fisheries, and urban sustainability. We work in partnership with policymakers, practitioners, and communities to co-produce knowledge. And the solutions to environmental and sustainability challenges require an understanding of their economic, social, and psychological dimensions.
Good day, everyone. This is Jaira Helbuena Monica, and I will be tackling all about Environmental problems. So what is environmental problems? Environmental problems are disruptions in the usual functions of ecosystems. Further, these issues can be caused by human or they can be natural. These issues are considered serious when the ecosystem cannot recover in the present situation, and catastrophic if the ecosystem is projected to certainly collapse. The environmental problem refers to a state in which the order and law of the ecosystems are collapsed as the ecological function it originally had is destroyed due to the influence of human activities. These environmental problems arise from conflicts between nature and humans. Here are the major environmental problems on Earth. First is pollution. Second is overpopulation. Third is poor waste management. Fourth is the climate change. Fifth is greenhouse effect. And the last one is the global warming. So what is pollution? Pollution is the introduction of harmful materials into the environment. These harmful materials are called pollutants. Pollutants can be natural, such as volcanic ash. They can also be created by human activity, such as trash or runoff produced by factories. Pollutants damage the quality of the air, water, and land. Many things that are useful to people produce pollution, and we all know that, like cars spew pollutants from their exhaust pipes, or even burning coal to create electricity pollutes the air. Industries and homes generate garbage and sewage that can pollute the land and water. Pesticides are chemical poisons used to kill weeds and insects, seep into waterways, and harm wildlife. All living things from one-celled microbes to blue whales depend on Earth's supply of air and water. This, when these resources are polluted, all forms of life are threatened. We all know that pollution is a global problem. Although urban areas are usually more polluted than the countryside, pollution can spread to remote places where no people live. For example, pesticides and other chemicals have been found in the Arctic ice sheet. And in the middle of northern Pacific Ocean, a huge collection of microscopic plastics particles forms, and it is known as the Great Pacific Garbage Patch. And this is not just normal. Great Pacific Garbage Patch is an area of the North Pacific Ocean where currents have dropped huge amounts of debris, mostly plastics. Next is the different types of pollution. First, we have the air pollution. So, what is air pollution? Air pollution sometimes is visible. For example, a person can see dark smoke pour from the exhaust pipes of large trucks or factories, and more often, air pollution is invisible. Polluted air can be dangerous even if the pollutants are invisible. It can make people's eyes burn and make them difficulty breathing. It can also increase the risk of lung cancer. Sometimes air pollution kills quickly. And in 1984, an accident at pesticide plant in Bhopal, India, released a deadly gas into the air. At least 8,000 people died within days. Hundreds of thousands more were permanently injured. Natural disasters can also cause air pollution to increase quickly, like when volcanoes erupt. They eject volcano ash and gases into the atmosphere. Volcanic ash can discolor the sky for months, and volcanic gases such as sulfur dioxide can kill nearby residents and make the soil infertile for years. Most air pollution is not natural. However, it comes from burning fossil fuels, coal, oil, and natural gas. When gasoline is burned to power cars and trucks, it produces carbon monoxide. It is a colorless, odorless gas. The gas is harmful in high concentrations or amounts. And also, city traffic produces highly concentrated carbon monoxide. Cars and factories produce other common pollutants, including nitrogen oxide, sulfur dioxide, and hydrocarbons. These chemicals react with sunlight to produce smog. It is a thick fog or haze of air pollution. The smog is so thick in Lithium, China, that people can seldom see the sun. When air pollutants such as nitrogen oxide and sulfur dioxide mix with moisture, they can change into acids. They fall back to Earth as acid rain. Wind often carries acid rain far from the pollution source. Acid rain can kill all the trees in the forest. It can also devastate lakes, streams, and other waterways. When lakes become acidic, fish cannot survive, like what happened in Sweden. Acid rain created thousands of dead lakes where fish no longer live, and acid rain remains a major problem here on Earth, especially in Asia. Chemicals called chlorofluorocarbons or the CFCs are a dangerous form of air pollution that may be found in gases that cool refrigerators, in food products, and in aerosol cans. Next is water pollution. Some polluted water looks muddy, smells bad, and has garbage floating in it. Some polluted water looks like clean, but is filled with harmful chemicals you can see nor smell. Polluted water is unsafe for drinking and swimming. Some people who drink polluted water are exposed to hazardous chemicals that may make them sick for years later. Others consume bacteria and other tiny aquatic organisms that cause diseases. The United Nations estimates that 4,000 children die every day from drinking dirty water. Sometimes, polluted water harms people indirectly. They get sick because of the fish that they live in. Polluted water are unsafe to eat. They have too many pollutants in their flesh. There are some natural resources of water pollution, like oil and natural gas. For example, it can leak into the oceans and lakes from natural underground sources. These sites are called petroleum seeps. The world's largest petroleum seep is the Coal Oil Point Seep, off coast of the US state of California. The Coal Oil Point Seep releases so much oil that tar balls wash up on nearby beaches. Tar balls are small, sticky pieces of pollution that eventually decompose in the ocean. Human activity also contributes to water pollution. Chemicals and oils from factories are sometimes dumped or sipped into waterways. These chemicals are called runoff. Chemicals in runoff can create a toxic environment for aquatic life. Runoff can also help create a fertile environment like cyanobacteria, and it is also called blue-green algae. Cyanobacteria reproduce rapidly, creating a harmful algal bloom product. HAB. Harmful algal blooms prevent organisms such as plants and fish from living in the ocean. They are associated with trade. They are associated with dead zones in the world's lakes and rivers, places where the little life exists below surface water. Mining and drilling can also contribute to water pollution. Acid mine drainage, AMD, is a major contributor to pollution of rivers and streams near coal mines. Acid helps miners remove coal from the surrounding rocks. The acid is washed into streams and rivers where it reacts with the rocks and sand. It releases chemical sulfur from the rocks and sand, creating a river rich in sulfuric acid. And sulfuric acid is toxic. It is toxic. It is toxic to plants, fish, and other aquatic organisms. Sulfuric acid is also toxic to people, making rivers polluted by AMT, dangerous sources of water for drinking and hygiene. Oil spills are another source of water pollution. Buried chemical waste can also pollute water supplies. For many years, people disposed of chemical waste carelessly, not realizing its dangers, and if not disposed of properly, radioactive waste from nuclear power plants can escape into the environment. Radioactive waste can harm living things and pollute the water. Another type of water pollution is simple as garbage. The Citarum River in Indonesia, for example, has so much garbage floating in it that you cannot see the water. Floating trash makes the river difficult to fish in. Aquatic animals such as fish, turtles, mistake trash as such as plastic bags for food. Plastic bags and twine can kill many ocean creatures. Chemical pollutants in trash can also pollute the water, making it toxic for fish and people who use the river as a source of drinking water. The fish that are caught in polluted river often have high levels of chemical toxins in their flesh. People absorb these toxins as they eat the fish. Garbage also fouls the ocean. Many plastic bottles and other pieces of trash are thrown overboard from boats. The wind blows trash out to sea. Ocean currents carry plastics and other floating trash to certain places on the globe where it cannot escape, and the largest of these areas, called the Great Pacific Garbage Patch, as we mentioned earlier. It is in a remote part of Pacific Ocean. According to some estimates, this garbage patch is the size of Texas. The trash is a threat to fish and seabirds, which mistake the plastic for food. Many of the plastics are covered with chemical pollutants. Last but not the least, the land pollution. Many of the same pollutants that foul the water also harm the land. Mining sometimes leaves the soil contaminated with dangerous chemicals. Pesticides and fertilizers from our agricultural fields are blown by the wind. They can harm plants, animals, and sometimes people. Some fruits and vegetables absorb the pesticides that help them grow. When people consume the fruits and vegetables, the pesticides enter their bodies. Some pesticides can cause cancer and other diseases. Trash is another form of land pollution. Around the world, paper, cans, glass straws, plastic products, and junk cars and appliances mar the landscape. Litter makes it difficult for plants and other producers in the food web to create nutrients. Animals can die if they mistakenly eat plastic. Garbage often contains dangerous pollutants such as oils, chemicals, and ink. These pollutants can leach into the soil and harm plants, animals, and worse, us, people. Sometimes landfills are not completely sealed off from the land around them. It's not that perfect, right? Pollutants from the landfill leak into the earth in which they are buried. Plants that grow in the earth may be contaminated, and the herbivores that eat plants also become contaminated. So do the predators that consume the herbivores. This process, where chemical buildups in each level of the food web, is called bioaccumulation. Pollutants leaked from landfills also leak into local groundwater supplies. Some communities do not have adequate garbage collection systems and trash lines beside of roads. In other places, garbage washes up on beaches. Trash is dangerous to ocean life and reduces economic activity in the area. Next is overpopulation. So what is overpopulation? Overpopulation is the state whereby the human population rises to an extent exceeding the carrying capacity of the ecological setting. In an overpopulated environment, the numbers of people might be more than the available essential materials for survival, such as transport, water, shelter, food, or social amenities. This regularly contributes to environmental deterioration, worsening in the quality of life, even disin- disintegr- disintegration of the population. It is estimated that about 81 million people add to the world's population annually. Regions with the highest number of population density, or the number of people living in a given region, feel the dire effects and problems of overpopulation. Due to immigration, the decline of mortality rates, medical breakthroughs, and increased birth rates, populations will always increase and eventually give rise to overpopulation. Overpopulation of the earth is a major problem on its own, but it also leads directly to other serious environmental impacts. One of those issues is overconsumption, especially of single-use products that damage the environment, slow the ability of the earth to renew its resources, and contribute to climate change. Next is poor waste management. So, what is poor waste management? Poor waste management is ranging from non-existing collection systems to ineffective disposal, causes air pollution, water and soil contamination. Open and unsanitary landfills contribute to contamination of drinking water and can cause infection and transmit diseases. The dispersals of trees pollute ecosystems and dangerous substances from electronic waste or industrial garbage puts a strain on the health of urban dwellers and the environment. The increasing volume and complexity of waste associated with the modern economy is posing a serious risk to ecosystems and also to human health. Every year, an estimated of 11.2 billion tons of solid waste are collected worldwide. Of all the waste streams, waste from electrical and electronic equipment containing new and complex hazardous substances presents the fastest growing challenge in both developed and developing countries. Household products, waste produced from houses, are a collection of all types of waste, in which include automotive products, skincare products, and many more. This causes waste production in tons, waste dumped in areas when not treated starts many, which cause the breeding of mosquitoes. These mosquitoes became the reason for diseases later on, like dengue. Plastic dumped as waste collectively decompose but increases underground pressure, resulting in earthquake. So, plastic dumped as waste can also be consumed by animals, resulting in internal injury or deaths of animals. Next is climate change. So, what is climate change? Climate change refers to the increasing changes in the measures of climate over a long period of time, including precipitation, temperature, and rain patterns. Climate change is sometimes mistaken for weather, but climate is different from weather because it is measured over a long period of time. Your areas of weather can change from day to day or from year to year. The climate of an area includes seasonal temperature and rainfall averages and wind patterns. Different places have different climates, like a desert, for example, is referred to an arid climate because little water falls as rain or snow during the year. Other types of climate include tropical climates, which are hot and humid, and temperate climates, which have warm summers and cooler winters. Climate change is the long-term alteration of temperature and typical weather patterns in a place. Climate change could refer to a particular location or the planet as a whole, and climate change may cause weather patterns to be less predictable, like what is happening right now, what we observe. These unexpected weather patterns can make it difficult to maintain and grow crops in regions that rely on farming because expected temperature and rainfall levels can no longer be relied on. Climate change has also been connected with other damaging weather events, such as more frequent and more intense hurricanes, floods, downpours, and winter storms. In the polar regions, the warming global temperatures associated with climate change have meant ice sheets and glaciers are melting at an accelerated rate from season to season. This contributes to sea level rising in different regions of the planet, especially here on Philippines. Together with expanding ocean waters due to rising temperatures, the resulting rise in sea level has begun to damage coastlines as a result of increased flooding and erosion. The cause of current climate change is largely from human activity, like burning fossil fuels like natural gas, oil, and coal. So next is greenhouse. What's greenhouse? Greenhouse effect is the heat in which escapes into space. The greenhouse gases block this escaping heat and hence it enters the earth. It is how the atmosphere retains heat as a result of the greenhouse gases have far-ranging environmental and health effects. They cause climate change by trapping heat, and they also contribute to respiratory diseases from smog and air pollution, extreme weather, food supply disruptions, and increased wildfires are the other effects of climate change caused by the greenhouse gases. The typical weather patterns we've grown to expect will change. Some species will disappear, others will migrate or grow. Next is the global warming. So what is global warming? Global warming refers to the rise in global temperatures due mainly to the increasing concentrations of greenhouse gases in the atmosphere. It is the consequences of unbalanced greenhouse effect. Global warming can result in many serious alterations to the environment, eventually impacting human health, and it can also cause a rise in sea level, leading to the loss of coastal land, a change in precipitation patterns, increased risk of droughts and floods, and threats to biodiversity. Besides the visible effects on people's livelihoods, global warming is predicted to have a strong and adverse impact on human health. The populations of countries that have contributed the least to global warming are the most vulnerable to death and diseases brought about by higher temperatures. The World Health Organization, or the WHO, reports that climate change is responsible for at least 150,000 deaths per year, a number that is expected to double by 2030. The effects of global warming will cause dire health consequences. Objectives of environmental geography. First is to create awareness about environmental problems among people, including you and me. Second is to impart basic knowledge about environment and its allied problems. And last but not least, develop an attitude of concern for the environment, to love our environment. According to UNESCO, environmental education should be compulsory, right from primary up to postgraduate stages. Environmental education should have an interdisciplinary approach by including physical, chemical, biological, as well as social cultural aspects of the environment. Objectives of environmental geography. First objective is to create awareness about environmental problems among people. Second is to impart basic knowledge about this environment and its allied problems. And last but not the least, it is to develop an attitude of concern for the environment. It means to love and embrace our environment. And according to UNESCO, environmental education should be compulsory right from primary up to postgraduate stages. Environmental education should have an interdisciplinary approach by including physical, chemical, biological, as well as socio-cultural aspects of the environment. And that would be all for today. Thank you for listening, and I hope you learned something from it. Thank you.